Good evening. My name is Rishi Shukla and I'm finally a BTech student. On the behalf of my team, I'm going to present my project, which is real-time sentiment analysis using deep learning method. The main aim of the project is to build a system which can analyze the human sentiments based on the facial expressions like happiness, sadness, angry, etc. Now, coming to the basic introduction of the project, here we have used FER 2013 dataset, which consists of grayscale images of size 48 cross 48 pixels. It consists of two types of data, testing data and training data. And it consists of seven types of emotions, that is angry, sad, happy, disgust, neutral, surprise, and one more. So here we have used convolutional neural network, which is basically for analyzing the sentiments of the images. It is the best architecture for the analysis of the sentiments in the images. And coming to the real life applications of the real time facial emotion detection, so naming them is human computer interaction and mental health monitoring, surveillance, and many of the other fields use this technique. So here we include those sort of basic layout is something like we have made a web interface using the Streamlit. So the Streamlit is going to be show the interface here. Firstly, the home interface will show the basic understanding of the web so that user can able to understand which part is shown here. And then two section is shown, which is while one is for the recorded and one is for the live capturing. So the recorded include the images and videos. Images, when you select the image and uh, the model going to process it. After that, the sentiment is going to be displayed. After that, the sentiment is going to be displayed. And for the video is going to be segregated in 20 frames, and with each frames the sentiment is going to be displayed along with it. So coming to the code, firstly I have already explained the Streamlit interface. Firstly, the home page, which include the welcome and the GitHub repo link. Along with that, there are two sections. One include the live capturing, other include the stored one. So this include the live capturing. If the camera unable to detect, then the failed statement, failed warning or failed error is going to be shown. Otherwise, it is going to detect the emotions based on whatever the emotions is going to, whatever the facial expression is going to be shown there. So here the model is loaded, which is in .h5 format. And for the stored data is also going to be the same thing, but it is somewhat different because it uses the uploading thing, which include uploading the data type of JPG, JPEG, PNG, MP4, and then analysis is going to be done. If the analysis is not able to do, then the error message is going to be processed. Otherwise, the emotion is going to be detected. Coming to the image code, so firstly, all the libraries are going to be imported, which is Matplotlib, Seaborn for the visualization, and apart from that, scikit-learn, TensorFlow, Keras is imported here. Okay, and the plotting of the image to check whether the images are going to be displayed correctly or not to match them. So this is displayed correctly. And after that, the segregation of the sentiments using pie chart and bar graph, which helps to understand the data in a better manner. As we can see here, this is the pie chart, segregation of the emotions, and here is the bar graph. Now the data pre-processing is going to be done, which include the image data generator, which consists of data augmentation techniques like zoom, shear, and horizontal flip, and many more, which helps to make the data more versatile and so that the model can help and able to analyze the images in a generalized manner. So it is a better way to make it more comfortable with the many of the images. After that, After that, the main thing which include is convolutional layer. So convolutional 2D layer is used with 32 filters, following by 64 filters. And after that, max pooling 2D layer is used, which helps in reducing the spatial dimensions. And after that, dropout layer, which reduce the overfitting, right? Overfitting, is going to be which is which going to be make your model accuracy not good. After that, batch normalization to make stable learning, and then the feature map is going to be flattened, and the soft max layer is going to display the output based on the emotions, 7 emotions. Okay. Now, after that, the model is going to be compiled with Adam optimizer. And after that, the plotting of the loss and accuracy over time is done to analyze how the uh, how the trend is going to be uh, displayed here. So the epochs is going to be done of 60. 60 epochs is run on this model to train it. Then the model is evaluated, and the visualization of the model based on the images. As we can see, the image is loaded here, and based on the images, sentiments is going to be predicted and it is going to be displayed. Similarly, we have done many of the testing with other emotions. Now coming to the real-time detection, same with the video analysis. Okay. Now coming to the real-time detection, here the real-time video capturing is done as we have already go through the image code. So this is going to be stored in .h5 format or .keras format, as we can see here for the future for the deployment of the model. Okay. Now here the model is going to be loaded, and then the feature are going to be extracted, and similarly video is going to be captured. If the video is not able to capture, then could not access the webcam. This type of error is going to be displayed. Otherwise, based on the labels, your emotions are going to be detected. And this is how the code is displayed. Okay. Now coming to the implementation. Let's see the implementation. I have already run the code. Okay. So this is the home page. This is the home page which displayed the stored and live capture data as these are the two sections. So upload data. Here we are going to upload the data, browse files, and we are going to upload what we going to upload. We should upload the video. Let's see the video. So first now, as we clearly see, this is the sad emotions, right? Let's see what is going to be displayed here. So the sad sentiment is going to be displayed, similarly sad. And this is how 20 frames is going to be displayed. We are not going to go through all the 20. Now, let's take a picture of a dog. Let's take a picture of a dog. Let's see whether it's able to analyze the emotions of the animals. So here the dog, how are you feeling? This is looking like a fearful, right? So here the dog is afraid of something. Capturing of the live data. So let's capture the live data. Here when we click on the start camera, the camera is going to be start, and the emotions along with that is going to be displayed. As you can see, this is happy, this is neutral, and this is fear, and this is surprise. So these are the emotions which is going to be displayed here. So this is real-time capturing. And this is how our whole project is going to be displayed. So thank you for the patience. So thank you for the patience and hope you have a nice day.